So first we're going to review how to factor. You should always start with factoring using a GCF if possible. So we're always going to check for GCF first. All of your steps are going to be given to you here in this middle column. I'm not going to read through them. I'm just going to do the example in the right-hand column and give you some notes. So both of these numbers or terms, 3x squared and 21, can be divided by 3. So that's my GCF. It goes on the outside. I open up a set of parentheses. 3x squared divided by 3 is x squared because the 3's divide out, and 21 divided by 3 is 7. You always check to make sure that you can't factor anymore. My inside binomial cannot be factored, so I'm done. Next is difference of two perfect squares. The formula is given to you here. A squared minus b squared becomes a minus b and a plus b. The order that you have it doesn't matter. So if you had a plus b first and a minus b second, that's fine. But the a has to come first because that was first in the question. So things you're always looking for are two terms and subtraction. And then you have to have perfect squares. So your exponents must be even. And your perfect squares for numbers 1, 4, 9, 16, 25, and so on. So 16n squared minus 1, both of them are perfect squares. It's a difference, and I have two terms, so I'm square rooting each piece, setting up two parentheses, one with a plus, one with a minus. Square root of 16n squared is 4n. Square root of 1 is 1. So, sum and difference of perfect cubes. Your formulas are given to you here. Things to look for this time. Two terms again. This time it can be addition or subtraction. But if I go back up to a second, dots has to be the difference. There has to be subtraction. So you might want to make yourself a note. If this was 16n squared plus 1, that's not factorable. So this time I'm looking for SOAP, difference of perfect cubes, or the sum of perfect cubes. My numbers are 1, 8, 27, 64, and so on. And my exponents must be divisible by 3. You are going to use SOAP to help you remember the signs. So I'm going to set up a small parentheses for my binomial, a bigger parentheses for my trinomial. Same sign, opposite sign, always positive. So this is a plus, opposite is minus, always positive. And then I'm going to set up my scrap work over on the side. So I'm going to cube root each piece. If you need to cube root the numbers on your calculator, it's math 4. The cube root of 8n cubed is 2n. The cube root of 125 is 5. Then I'm going to square, multiply, square. So 2n squared, remember that you're squaring both the 2 and the n. So this is 4n squared. 2n times 5 gives us 10n. And 5 squared gives us 25. So those pieces go directly into your binomial and trinomial that you have set up, the parentheses. So it becomes 2n 5, 4n squared, 10n, 25. And this is your answer. Now let's move on to trinomials. So trinomials means that I have 3 terms, and there are 2 different situations here. So here I'm working with 3 terms, and notice that there is no number in front of the x squared. It's always going to be a 1x squared. If you have a number in front, you're going to look for the next set of directions or the next method of factoring. So 2 parentheses, Square root the first piece, so this is r and r. Bring down the first sign, which is a negative. Then I take my two signs, a negative, and multiply them together to get a positive. So my next parentheses is positive. If you need to, go to the calculator. You're looking to multiply to 18. So y equals 18 divided by x. 1 and 18, 2 and 9, 3 and 6. Now I'm looking for the pair that combines to give me 3 using the signs I already have set up in my parentheses. Should be 3 and 6. Your bigger number always comes first. So r minus 6, r plus 3. When you have a trinomial, which is 3 terms, but there's a number in front, first you're always going to check for a GCF first. If there is a greatest common factor of everything, meaning all 3 terms can be divided by something, you're going to do that. Otherwise, you're going to follow these steps. So I check here. There's nothing that 8, 10, and 3 can all be divided by. So I'm going to multiply A times C. So 8 times 3 gives me 24. That's the number that you're going to put in your calculator and list out your factors of. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those outside pieces are going to come down with 2 blank spaces in the middle. You're going to use your sign trick to figure out the signs of your blank spaces. So this is a this is a minus, because I bring down the first sign, and then a negative times a negative is a positive. So I need 2 pieces that combine to give me 10. But remember, the bigger number is going to be a negative, and the smaller number is going to be a positive. So it's going to be negative 12 and positive 2. I'm splitting up a 10x, so it's going to be 12x and 2x. And then I'm going to factor by grouping, which is actually our next method, which I'll do in a second. But when you factor by grouping, you look at the first 2 pieces. These 2 have a GCF of 4x, so that comes outside. 8 divided by 4 gives me 2. X squared divided by x gives me x, minus 12 divided by 4 gives me 3. My x's divide out. My next 2 pieces, I'm looking for a GCF. Remember, you can always use 1 as your GCF, and you always want to bring down this sign. So there's nothing they have in common, so when I take out a 1, I'm still left with 2x minus 3. Notice how my parentheses match, so I'm going to keep that. If your parentheses don't match, something went wrong. And then my other 2 pieces come together in the second set of parentheses. And then lastly, grouping. You're going to do grouping when it's 4 or more terms. And we just did a little review of it, but I'll go through it again. You want to break it up into groups like we just did. I always try 2 at a time first. Sometimes if that doesn't work, you go to 3 at a time. Sometimes you'll need to rearrange. That's okay too. So my first 2 pieces can be divided by x squared, which goes on the outside. I'm left with x plus 5. Next 2 pieces, I'm always taking out this sign here, can be divided by 9. I'm left with x plus 5. Parentheses match, so I know I've done it correctly. That gets written 1 time. Other 2 pieces go together. And we also want to talk about the idea of factoring completely. Factoring completely means that you are always going to factor until you can't anymore. So if you take a look at this example, one of my parentheses is x squared minus 9, which is dots. So I bring down the x plus 5 because I didn't use it. And then dots is 2 parentheses, 1 plus, 1 minus, square root of x, square root of 9. Here is my final answer. And then, of course, you do have calculator tricks that you can use to help you factor, especially on a multiple choice, or to kind of fake it and work backwards on a free response. Those were all polynomial expressions. These are now equations. So when we have an expression, we factor. When we have an equation, we solve. Factoring questions get left in parentheses, but solving equations, we always have a final answer of x equals, and we're always going to t off. Whenever we are solving, we always want it equal to 0 first. So if it's something like x squared plus 5x equals 7, before I can factor, before I can use the quadratic formula or do anything else, I always want to set it equal to 0 to start. And that's true whether it's quadratic, cubic, doesn't matter. Expressions and equations should always be in what we call standard form. So just like you want it to be equal to 0, you want it in standard form. Meaning, if it's quadratic, it's going to be ax squared plus bx plus c. If it was cubic, it would be ax cubed plus bx squared plus cx plus d. You always want your exponents to go from the biggest to the smallest. If a solution cannot be factored, or an equation cannot be factored, we are going to use the quadratic formula. Remember that it is on the reference sheet, so you don't need to memorize it, but you need to know when to use it. So a key phrase is going to be simplest radical form. You also may see simplest a plus bi form, or rounding instructions, because if I factor, we usually don't get decimals. So any of those are your signal to use the quadratic formula and not waste time trying to factor. If solutions are imaginary, that means I can't factor either, which is why you would see the simplest a plus bi form, which is down here as well, but I wanted to put it up top so that way everything's all together. Calculator tricks when you are factoring and solving are similar. When you are solving, and I'm looking for a solution, remember we can always do a point of intersection with y1 on the left side, y2 for the right side, and using second trace 5 or going to the table. And you can always look for your zeros in the table or your x-intercepts on a graph. Operations with polynomials. When we combine like terms, we add or subtract our coefficients. We do not change our exponents. That's for adding and subtracting. When we subtract, you must remember that you have to distribute your subtraction sign. So for example, 5x squared plus 2 minus 3x squared plus 7. This subtraction sign, whether you leave it as a subtraction or you make it a -1, must be distributed to everything inside the parentheses. Your key phrase for when you need to reverse the order is when you see subtracted from. Remember that from comes first. Cost, profit, and revenue is a word problem that we see many times for adding and subtracting of polynomials. It's profit equals revenue minus cost. Sometimes they give you this formula, sometimes they don't. So I do want you to have it in your notes in case you need it. So operations with polynomials, that's adding and subtracting. Let's move on to multiplying. When we multiply, we use the box method or we double distribute whenever needed. You have to remember that when a binomial is squared, you must expand it. What does that mean? X plus 5 squared is really x plus 5 times x plus 5. There are no shortcuts. Draw out your box. Label x plus 5 on both sides, top and right. Remember that when you are multiplying, we add our exponents. So x times x, these both have an imaginary 1. 1 plus 1 gives me 2. So this is x squared. 5x, 25. To get out of the box, we add on the diagonals. So x squared plus 10x plus 25 would be this answer. When you're using the box method, please remember that you must use a placeholder if needed. So for example, if this works with division as well, which we're going to do in a second, if it was something like 3x squared plus 7, we would need to do 3x squared plus 0x plus 7. Dividing polynomials, we're going to go through synthetic division. This method only works if the divisor is linear with no coefficient for x. There is extra steps for your coefficient of x, which we're not going to go through right now. You're going to set your divisor equal to 0 and determine the number that goes on the shelf. So let's look at the example. This is my divisor. So x plus 2 equals 0, x equals -2. That's the number that's getting lined up on my shelf. You're going to line up all of the coefficients in the numerator. So this is going to be 2x cubed plus 5x squared plus 0x with my placeholder minus 4. So we have 2, 5, 0, -4. We always bring down the first term, and then we follow the pattern of multiply and add. So 2 times -2, it's the bottom number times the number on the shelf, is -4. Add straight down. 5 plus -4 is 1. Multiply. 1 times -2, -2, add straight down. -2 times 2, 4, add straight down, 0. So this last piece is always our remainder, and then we build our polynomial backwards. This is my constant, x to the first, x squared. So this is 2x squared plus x minus 2, and it has no remainder. Remember that division problems are always written for my answer as quotient, and then if there's remainder, it's plus the remainder over the divisor. So factor and remainder theorem. We set the divisor or the factor equal to 0 and solve. Something is a factor if there is no remainder. So for example, that last division problem that we just did above for synthetic, that was a factor because it had a remainder of 0. On a graph or in a table, the remainder is given by the y value. So on my calculator, I'm always looking for the 0 in the y column. And this can only be used if they ask about a factor or a remainder, or if it's multiple choice. If they're asking you to divide or find a quotient on a free response, you must do synthetic division. So let's go to our polynomial vocabulary. The degree of a polynomial is the largest exponent if I'm in standard form. If the polynomial is in factored form, you have to add the highest exponent from each factor. So an example of that would be f of x equals x squared plus 2 times x plus 3. This would be 2 plus 1. It would have a degree of 3. When a polynomial is in standard form, our first term is known as our leading term, and the first number is known as the leading coefficient. So I have an example right below that we're going to talk about here. My leading term is 7x to the 5th. This is in standard form. So my highest exponent is 5, which means I have a degree of 5. My leading coefficient is 7. At the back, this is a constant. It's the number without a variable. 6x would be my linear term. -1x squared would be my quadratic term. So I'm going to list those all out here. X to the 5th is quintic. X to the 4th is quartic. X to the 3rd, cubic. X squared, quadratic. And x is linear. A coefficient is the number in front of the variable, and the constant, like we said, is the number with no variable attached. A 0 is where the graph touches or crosses the x-axis. A factor is an expression such as x plus a number or x minus a number. So x plus 3, that's known as our factor. X equals -3, that's known as our 0. So now let's talk about their graphs. An x-intercept is the same thing as a root, a zero, or a solution. If you need to find the roots algebraically, we're going to factor and t off. If it's not factorable, you're going to use the quadratic formula. If you can find them graphically, we look on the x-axis or when the table has y equals 0. Multiplicity is the number of times a polynomial has a root at a given point. In an equation, we look to our exponent, and on a graph, we look at its behavior. So for example, if it goes straight through like this, it has a multiplicity of 1. If it has a bounce like this and is what we call tangent, it has a multiplicity of 2. If it squiggles through the axes, it has a multiplicity of 3. In terms of end behavior, even degree polynomials have arrows that point in the same direction. So even would look like this or like this. Odd degrees have arrows that point in opposite directions, like this or like this. To determine which way it faces, we look to the right arrow, and that determines the sign of our leading coefficient. So even positive, like this, even negative, like this, odd positive, like that, odd negative, like that. The negative or the positive is my right arrow. End behavior, here's your notation for it. Remember that as x goes to infinity, that's talking about your right arrow because x's are left and right, so the right side is positive infinity. As x goes to negative infinity, that's your left arrow. And then f of x is like y. You want to know where is the y value pointing. If it's pointing up, it's going to positive infinity. If it's pointing down, it's going to negative infinity. Imaginary numbers. A complex number is a number that can be expressed in the form a plus bi. A is our real number, I is our imaginary number. Most of what we do in this course with imaginary numbers is done in the calculator. So remember that to get a decimal, to get an I on your calculator, it's second decimal point, that gives you the I. Most of the operations, unless there's a variable in it, can be done in the home screen of your calculator. When that doesn't work, if you get a strange answer like I plus E something, that means you're going to go to I part, which is math, and go to the right and choose number 3. You can never leave anything greater than I in your answer. So if it's I squared or 7i to the 5th, you need to use your calculator to simplify that before getting your final answer. And the most important part for us in this course is imaginary roots. Imaginary roots do not cross or touch the x-axis. So it would be something like this. This parabola has no x-intercepts, so therefore it has no real roots. I would anticipate when I solve, they are going to be imaginary roots only. Imaginary roots always come in pairs, and imaginary solutions cannot be found by factoring. So we need to use the quadratic formula. If it's an algebraic question, something in the question might say, express your answer in simplest a plus bi form, which we talked about earlier when we did the quadratic formula for those notes. And that's the most important part. If I have something like x minus I squared, you cannot use the calculator. You have to do the box method for this. But if I have something like 7 plus I squared, that can go in the calculator. Or if I have something with a variable on the outside, you would be able to do this part first in the calculator and then distribute your answer with the x after the fact.